Let's have a look on how we can integrate geological information in our design process. So here we are connecting to the Open Ground cloud projects to access the geological information. So connecting to that project, and we'll see the information. Here it is. We have the field geological description. We can do different mapping. We'll see later what does it mean. Mainly it's symbology that we get out of there in OpenRail or Open Roads Designer. So I carry the information, and as you can see, we get the boreholes in the 2D, in the 3D with a symbology. That's where the mapping is playing a role. So here we have all the information coming from Open Ground. This can be changed in Open Ground, by the way. And we can see here the name of the stratum. We have the information on the borehole. So really straightforward to access the information. So to connect this and to import this information in OpenRail or Open Roads Designer, you need an access to the Open Ground project. Once it's there, you can use without any license to connect to Open Ground. So we can continue to configure and edit the information within the design file here to the DGN file, changing like the radius for the boreholes. We can do this for the dynamic cross-section, 3D profile. This is all managed by templates, really common way of managing information in MicroStation or our civil products. You can change the color, you can add some information, just using the standard tools. As you can see, we map to this property general description of stratum. But again, you've got freedom here to do what you want to do based on what you've got from the Open Ground project. We can annotate the boreholes using Civil Labeler, where you can customize the information to display. Here I am annotating with the borehole ID, the final depth, and termination reason. So I selected all the boreholes and I'm placing the annotation. We can also carry documents that are attached to the borehole in Open Ground just by selecting the borehole and select the document I want to see. Here, a PDF. If we look at another borehole, there is another type of document, in this case, a picture. Hence, we can create a log, or carry a log of the borehole. And I would get this kind of report or document. So the next thing we can do here is add information coming from Leapfrog in this case. So you can imagine this workflow when Leapfrog is connecting to Open Ground, it gets the information from Open Ground to create the geological layers by geological engineers. We can create meshes in Open Roads, OpenRail using the boreholes, but it's the best practice to use Leapfrog to put some engineering, geological engineering in there. So as you can see, I can import the IFC coming from Leapfrog. So I've got all the information here. And if we look, we have this item, the IFC properties, coming from Leapfrog again. We have all the categories. So I have just one thing to do is to map this to what I want to use in my civil product. So basically, I would just right click, do a select, and assign a feature definition. Just pick it from my OpenRail here and set the feature definition. And I have feature definitions, just mesh feature definition, matching what I have in my IFC in this case. And I repeat this for my layers. So that if you want to group some, you can group some in the same feature definition if you don't need all the details. We will use this for, of course, quantities and other purposes. And the last one, as you can see, easy process. In the future, we may have a direct connection from OpenCivil to LeapFrog so that we can get all of this done automatically. But for now, you can see that's not difficult and long to do that. So now I have my TGN with all the geological information ready. And as usual, I can use in my design as a reference. And where it's reference, I can get all the information coming from the objects in the TGN. So let's turn off the layers so that we can see the boreholes. As said, you can select the boreholes and see all the information using the properties. So full awareness of geological and geotechnical conditions while you are designing. And of course, we can see this also in the 3D, the same information. You can use to design, so the profile, and you will use for the corridor and the quantities. But first, let's project these boreholes to the profile. So from the geotechnical extension, we've got this tool to project the boreholes on the profile. So you can first select all the boreholes you want to project and then run the command and just select the alignment. And that's it. And based on the symbology, so the fits definition, of course, you can see the hatching. And again, we have all the information about the geological or geotechnical from the borehole. But we also have the layers coming from LeapFrog imported as IFC. So it's something we can get also in our profile just by using the 3D cut here along the full profile. So you can see how easy it is to get all your geological technical information in your design workflow. So now you can anticipate and maybe change the profile to avoid some layers or whatever. So we can now create just a sample corridor along this alignment and check how we can use again this geological information in our design workflow. Here it is. I have my corridor, so I can look at the cross section. And again, I've got all my geological information without any action. It's there because it's in the 3D model. So I can navigate and I can see all my layers. And then I can elaborate template and condition in this case, so that I can set my layers, in this case the saprolite. As you can see here, I can simulate and draw my saprolite and move up my ground to check what will happen when using this in my model. So now I'm just using define target aliasing to add the layer, the saprolite, to the corridor so that it can target this layer. So again, I can directly use the mesh coming from the IFC, but where I assign a feature definition, and that's it. So I must change my template just to use the end condition created before, and that is targeting the saprolite. So let's delete these components and replace with my component, my end condition component. I can just drag here and do the same. We will reflect for the other side. Again, good practice to test a little this, and again, we can simulate the existing. Does work well, and if we find the saprolite, then we can see that we have the little berm. And that's it. So now let's navigate where we have the saprolite, and you can see here the result. Again, we can target multiple layers if needed, bottom or top of the layer. And here, just to have a quick look on the location of a borehole, where we can see also the hatching and the boreholes in the cross section as we do in the profile. So last here, we can use the layers for quantities. So in another file referencing my design, usual workflow with OpenRail, I'm creating the cut and fill mesh and using the substrate. So it's calculating based on the 3D mesh, and would extract and create objects, meshes for each layer, as we can see here in the cross section. We can see the shape of the mesh. So we have the quantities in the 3D model ready for BIM workflow to export to IFC to connect to the iTwin. Try to see a little more here. You can see all the meshes created in my 3D model. Easier to see on the cross section usually. But again, all is there. So now I can calculate the quantities, and you can see my report including all the quantities for the each layers. And that's it.